Hello, let me start by introducing the Web-Based Systems Group. So we are located at the School of Business and Economics at the Free University of Berlin, and our main research focus are linked data technologies for extending the World Wide Web with a global data commons. Currently we are present in 3 big European projects. One of that is LOD2, which is that webinar currently being done at. Then there are 2 others, the Lattice project and the Planet Data project, and all 3 of these projects are concerned with linked data technologies. And you can visit us on our homepage at wbsg.de. I want to briefly introduce our main projects our working group is working on. That's the Wikipedia project, which is probably the most popular of our projects. That's a community effort which is led by our group and the AKSW group at the University of Leipzig. Wikipedia is mainly an effort to extract structured information from Wikipedia and make this information available under an open license. And one of the main objectives of Wikipedia, apart from offering the structured data, is to interlink all these entities in the Wikipedia dataset with other datasets on the web of data. And there's one tool we offer, which is Wikipedia Spotlight, which is a free text annotation tool which can be used to annotate free text with Wikipedia URIs. Another a popular tool provided by us is the D2R server, which is a tool to publish relational databases on a semantic web. So basically it makes relational databases available, offering a SPARQL interface and a linked data interface. And apart from that, we have a couple of projects in the data integration space. So that starts with R2R, which is for translating linked data sources into a common vocabulary. And secondly, this is the Silk tool, which this webinar will be about, so I won't go into detail for that one. And finally, we also have the linked data integration framework, which is a framework which combines R2R, Silk, and other tools to translate the heterogeneous web of data into a clean local target representation while it keeps track of the provenance of the data. Okay, so let me start with the motivation for our problem here, and remember that every time you have a question, you can ask them into the chat. So what is the problem we are facing here? So the web of data is a single global data space which is currently consisting of about 30 billion tuples, which are published according to the linked open data principles. But the problem here is that only 500 million links of these 30 billion tuples are actually connecting entities between data sources. And most of the publishers for linked data sources only link to one other data source, which means whenever we consume linked data, we need to generate additional links in order to being able to have a homogeneous view on this data. So what are the challenges we are facing if we want to generate these links between entities? So first of all, the web of data is very heterogeneous. So we have many different vocabularies. So we can see here on the graph there are some vocabularies which are in wide use. That's, for example, Dublin core vocabulary to represent properties of documents, or for example the FORF vocabulary to represent properties of persons. But there are many smaller vocabularies which are used by 1 or 2 data sets, and many data sets even use their own vocabulary, which only is used by that specific data source. So if we want to interlink these data sources, we are facing the problem that we need to take care of different data formats, of different vocabularies, and so on. Secondly, there's a large range of domains. So currently the web of data, we count about 277 data sources. And for all these data sources are from different domains, and in each of these domains there are different ways to represent the same information. So we have a similar problem here. We need to write different rules for each of these domains to actually interlink these data sources. And finally, there's the problem of scalability. So as I said, we have 277 data sets, and there's over 30 billion tuples in total, which makes it obvious that we need some method to actually scale to that size. Okay, what's the common solution to that? So there are a number of link discovery tools. So the purpose of these tools is to actually identify entities in different data sources which identify the same real-world object. So for that, most of these tools employ a so-called linkage rule. I will later go into more detail about what exactly a linkage rule is and how it is built. And there are a number of popular link discovery tools at the moment. So for once, there's the Silk Link Discovery Framework, but there's also LIMES, and there are many others you can find under this URL. So this talk is about the Silk Link Discovery Framework. I will give a few details. So as I said, it's a tool for discovering links between data items within different data sources. And this link discovery is based semi-automatically on linkage rules, which are written using the Silk Link Specification Language. And Silk can be used to identify same-as links, which means we are identifying entities which represent the same real-world objects but are duplicates, so which means they have different URIs. But it may also be used to identify different kind of relationships. And the special focus of Silk is on scalability and high performance. We are offering different versions of Silk, so which can be used for different use cases. So the most common use case is to generate links on a local machine, just using really one processor and one machine. Another use case is usually, as we have seen, that we really need to scale here to a really large data sets. So for that we offer the Silk MapReduce version. The point of that is to really execute the Silk linkage rules on a cluster of machines. So Silk MapReduce is based on Hadoop, and it can, for instance, it can be run on Amazon Elastic MapReduce. And finally, we also offer the Silk server. So while the first two applications are pure batch mode, batch applications, so you give them a linkage rule and the data source and you get the links, the Silk server is more dynamic. So it, as the name suggests, it's a server that reads an incoming stream of instances and interlinks these instances on the fly while keeping track of duplicates. And it can, for instance, be used as the identity resolution component in an application which consumes linked data from the web. So before I start to getting into more concrete use cases, I will present a very simple linking workflow. So basically we need to do 3 steps in order to interlink 2 data sources. So first of all, of course, we need to select the data sets. And usually one data set may contain different types of entities. For example, the DBpedia data set may contain persons, geographic locations, movies, and so on. So usually we do 2 things. We select the data sources, and in each data source we select the type of entity which we actually want to interlink. That's the first step. The second step is we write a linkage rule. The linkage rule, as I said, specifies the exact conditions which must hold true for 2 entities to be a link to be generated. So these linkage rules can either be written manually or they can be learned using machine learning. We will later see an example of this. And finally, the third step is to actually generate these links. This can either be done locally or it can be done on a Hadoop cluster using Silk MapReduce, and these links can either be written to a file or they can be directly pushed to a triple store. Okay, so what is the linkage rule? How it is composed of? So in the context of Silk, we will present a linkage rule consisting of 4 operators. So at the bottom we have the RDF path. So usually, first of all, we need to select the properties by which we can compare 2 entities. For example, we may select the label of a person if we want to interlink persons, or if we want to interlink movies, we also may give it a path like the label of the director of a movie. So if we have selected these discriminative property values of an entity, we need to take care of that different data sources, as I've already said, may use different data types, different vocabularies. So secondly, we usually need to apply a couple of data transformations in order to normalize the values prior to comparison. So for that, for example, we may use the lowercase transformation in order to normalize the case of the values in the case that different data sources use different letter cases. So if we are at the point that we have actually selected the properties by which we want to compare, we can apply a number of similarity metrics on these properties. For example, we may use various string similarity metrics, but we also may use geographic similarity, date similarity, or other special purpose distance metrics. And finally, usually we face the problem that we cannot compare two entities by looking at a single property alone. So for instance, we cannot just look at a label. We usually need to look at other properties as well. For instance, if we interlink movies, we may need to look at a label as well as the release date. We will see later an example for that, and for that we need an aggregation operator which aggregates multiple similarity comparisons. So what is the Silk workbench? So far we only have considered like command line tools, and the Silk workbench is a graphical web application which guides the user through the complete process of interlinking different data sources. And for that it enables the user to manage different sets of data sources and linking tasks. If we want to interlink like multiple data sources or multiple types inside one data source and so on. And it offers a graphical editor to actually edit linkage rules and to execute them. And it supports for learning linkage rules. We'll also see an example for this later. So now I want to go through the different features, briefly have a look at them. So first of all, I said the Silk workbench allows the user to actually manage different data sources and linking tasks. So what is a data source? So data source holds the information which is needed to retrieve a specific data source, and it may be a file dump or also a Sparkle endpoint. And on the other hand, we have linking tasks. A linking task specifies how two type of entities are interlinked. For example, a linking task may specify how we can interlink movies in DBpedia and linked MDB. Secondly, we have the linkage rule editor. So this is a graphical editor for linkage rule, which shows the linkage rule as a tree, and linkage rules can be edited through drag and drop. So I will now skip through it as we will see an actual example later. And finally, we have support for, as I said, learning linkage rules, which interactively through user interaction may learn a linkage rule, and the learned linkage rule can later be viewed by the user and modified by the user. Okay, as this probably sounds rather theoretical, we will now have a look at a practical use case and view a screencast showing how Silk Workbench is actually used to interlink a simple example. So the first demo we will see is how we interlink DBpedia and linked MDB. So DBpedia, as I already presented, is a large data set extracted from Wikipedia and contains many types of entities. And amongst others, it also contains movies. And linked MDB is a big database for movies, which is published as linked data, and in that sense is similar to IMDb. And for demonstration here, we assume there are no existing links, so we assume that these two data sources are not interlinked so far. Okay, so here we see on the Silk Workbench the initial view. So we see there's no project currently, so we start by creating a new project, which we call linked MDB, because that's actually the data source we want to interlink. So we now need to define 4 things. We need to, and we'll now go step by step through it. So first of all, we need to define prefixes, then we define data sources, linking tasks, and outputs. So for prefixes, that's an optional step which we purely do because URIs usually can get pretty long, and we want to have it visually more pleasing by having them shortened. So we define a prefix for the linked MDB and the DBpedia URIs. Secondly, we need to define the data sources which we actually want to interlink. So first of all, we define how the DBpedia data source is accessed. We have now 2 possibilities. So either define the public SPARQL endpoint of DBpedia, or what we also can do, and which we will do in this demo, is to define a local RDF dump of this data source. The Silk Workbench supports all common formats of RDF dumps, which is RDF XML, N-Triple, Turtle, and N3, and so on. In that case, we just load a dump of using N-Triple's format. As you can see, we now defined our first data source, and we will now go on defining the second data source exactly the same way as we did for the first one. So again, we define a local dump of where this linked MDB is actually located at in our local file system. Specify the format and save. So after we have now defined 2 data sources, we'll now go on by defining a linking task which actually interlinks these 2 data sources. What we want to interlink is movies in that case, so we select a source in the target data sets, which in our case is DBpedia and linked MDB, and in that simple demo, we leave the restrictions empty, so we interlink the complete local dumps. And usually after we have generated the links, usually we also want to write them to an output. So Silk supports file outputs and SPARQL update outputs. In our demo, we will just write all the links to a local file in the file system and just using the N-Triple's format. So at this point, we have defined a very simple project. It consists of 2 data sources, 1 linking task which interlinks these data sources, and an output. We could now go on and edit this project or add more linking tasks, but instead we will now open the first linking task, which we actually want to edit now. And as we remember, what we need now as a second step is we need the linkage rule. We could now go on and use the editor, which we can see now, to actually create the linkage rule from scratch. But what we will do instead in this demo is we want to learn the linkage rule using active learning. So for this, we click on the Learning button, Learning tab, and we just click on Start to actually start the learning. In the beginning, we usually need to wait a couple of seconds. Okay. What we see now is that on the upper side is the first linkage rule, which has been learned, which is very rough because the workbench actually does not have any information about how the data sources could be interlinked. So it's doing a very rough attempt to interlink them, and in that case it's interlinking them by comparing the title and the label of the properties using the Levenstein distance. And on the lower side we can see 3 links for which the current learning algorithm is very unsure, which is very uncertain. And the workflow now is that we have a look at these links, and as we can see, they are not marked either as correct or incorrect, so the learning algorithm is uncertain for it. And the workflow now is that we need either to confirm or decline these links in order to help the algorithm to identify the correct linkage rule. So what we see here are two movies, because we're interlinking movies. Both movies have a title and a date, and in this demo we just focused on the first two properties. So we don't look at the complete entities, but only at the first two properties, the date and the label of the entities. So what we are actually doing now is that, as I said, we are looking at the date and the label, and we see that both movies are the latter, and they're both from the same date. They're both from 1940. So what we do now is to click on correct. We tell now the algorithm, so okay, these two entities are actually representing the same movie. So we click on correct, and the algorithm now relearns the linkage rule and gives us new links for which is still uncertain. So usually at the beginning, so we are starting from scratch here, so we don't have any information at all. We need to confirm or decline a couple of links. So we now go just through it. See, the next movie is a Shoah from 1985. And as we can see, this also is the same movie from the same date. So we just go on and confirm a couple of links. Next movie is The Count of Monte Cristo from 1954. We see here the data is a bit noisy. We have two release dates, but that doesn't matter. But what the problem here is that we have just identified the first special case. Both movies are called The Count of Monte Cristo, but here the second one is from 2002. And if we go back and look at the first movie, now we see that this movie is actually older, so it's another movie. It has the same title, but this is different movies. And if we now look at again at the linkage rule, which has been learned so far, we see that this linkage rule compares by the name, or actually by the title of the movie. So this means that if two movies have the same title, they will be interlinked. But now we can see, after we have identified or the learning algorithm has identified the first special case, is that for these two movies that wouldn't work, that would fail for these two movies. So now we see what happens. So we tell the learning algorithm, so actually these two instances are not the same movie. The learning algorithm now relearns the linkage rule, and as we can see, it has presented us with a new linkage rule, and now it compares by date. So apparently for all movies which we confirmed so far, it works that we just compare the release date of the movie, and by that identify if two movies identify the same actual movie. In order now to go on with the learning, we just confirm or decline a couple of additional links. And we can see here that these two movies have the same release date, but they have different titles. So for these two movies, this linkage will fail, so we decline them and tell them, no, actually, this is not the same movie. And we now do that for a second one. So the purpose of the learning algorithm here is that it tries to present us the links which are not yet known, which identify special cases for which the current linkage rule may fail. So we can see here that this movie is The Cutting Club from 1984. And here we have also a movie from 1984, but this is called The Tune. So we can see here that's the second special case. So two movies from the same release date, but with a different title. And if we look again on the linkage rule, we see that for this case, this linkage will fail again. So we have now seen two special cases. In the first special case, it didn't work to compare by label. And now in the second special case, we see it actually doesn't work either to compare solely by the date. So we now see what happens. So we tell the linking algorithm, so now these are different movies. And the learning algorithm actually has to work now a bit, but presents us now with a new linkage rule which covers all cases which we confirmed to the client so far. And if you look now, what happened is that actually it learned now a linkage rule which compares by both properties. It compares by release date, but it also compares by the label. And it aggregates both similarities using a minimum aggregation, which is equivalent to an AND. So what we have here is two movies must be similar by release date and by the title of the movie. So what we could do now, we could go on and confirm or decline further a couple of links, but instead now we say, okay, we are okay with the results so far, and we click on done, and now it presents us with the current learned linkage rules. So usually it doesn't learn a single linkage rule, it learns a population of linkage rules. So it gives us now a couple of alternatives, and for each alternative it shows us the F measure compared to the rules we have so far, to the links we have so far. Here we can see the linkage rule which we already know, which compares by date and label, but we can also have a look at alternative linkage rules which are not completely covering the solution space. And here, for example, we see a rule which only compares by the title, which gets almost 90% of all reference links, but not all reference links. So what we do here is we just select the first linkage rule and want to load it into the editor and maybe further edit the linkage rule. So we click on load, and now we see our editor again, but this time on the linkage rule which has been learned is preloaded into the editor, and now we can have a look at it. So basically, let me say a few words about the editor. So what we have here is basically the four kinds of operators which we already knew from the initial slides. So what we have here is in the top left corner is we have the properties which are available on the entities. So we have a source data set, which is DBpedia. You can see here all the properties on DBpedia, and then we can see all the properties on the second data source as well on the linked MDB dataset. And as we remember, usually we need to apply data transformations in order to normalize the values of each property. For that, we now see here a big selection of data transformations which we may apply. And the third operators are the comparisons. We here see a lot of different distance measures which we can use to compare different properties. And finally, we also have a number of aggregation functions to aggregate the similarity of different comparators. So now let us use these operators to make a little minor changes to our linkage rule. So first of all, what we may consider is that the case of a movie is not always the same. So sometimes it's spelled uppercase, sometimes spelled lowercase. So what we want to do as a first step is to normalize actually the case of the title. So what we do, we just drag in the lowercase transformation and we connect it to the title properties. And now we can, if we want to reuse the Levenstein distance, but actually what we want to do, we only want to consider movies with exactly the same title. So what we could do now is to lower the threshold to 0, but actually what we do now is we just take the equality comparator. So we only consider movies which have the same date if we ignore the case of the letters. And what we also did here is we clicked on the required because we want only want instances for which both is defined, the label as well as the release date. And we also lowered a bit the date threshold to 300 days. So we can see here the description of this comparator, of the date comparator. That's just the distance between two dates in days. So we just lowered that to 300 days. Just for simplicity, we give the comparators nice names. Okay. Now we can see in the upper right corner again that we still have the full precision and the full recall. So we are still covering all reference links which we have found so far. So the next step we now want to do is we actually want to generate links from this linkage rule. So we go to the Generate Links tab and we just click on Start. And here, as we remember, we defined one output which we called file. We select this output and click OK. So we wait a couple of seconds until the links are generated. As we can see, they're already shown here. And we can now select a single link and have a look at the details, how it has been generated. And we see here identify the linkage rule we've already know, and we see in that case we have a movie which is called Hot 8 and which is from 1997. And this is, it's 100% similar. So that's not very interesting. Actually, usually we are interested in the cases where with near duplicates and exact duplicates, but near duplicates where there's some noise inside. And we now ordered all the links by score, and we now look at the link with the lowest score that actually has been generated. And what we can see here is that the title is exactly the same, but the date is a little bit different. So apparently there's an error in the release date. So both data sources are not offer different release dates for the same movie. But we defined a threshold of 300 days, and that's still inside the threshold. Okay, and we can also now have a look at the file which has been written to the output, and we see all the links have been written in n-triples format as we have specified. Okay, so we have now defined a project, we have learned the linkage rule, we have adapted, modified the linkage rule until we have been happy, and we generated links for it and wrote them to an n-triples file. So that concludes our first demo. Okay, now let's have a look at the second demo. So in the first demo we assumed that there are no reference links at all, and we used the active learning feature of the Silk workbench in order to interactively learn a linkage rule, like from zero. And now in the second case we have a look at the CORA dataset. So the CORA dataset is a popular dataset from record linkage which contains many citations to research papers, and many of these citations are duplicated, and the goal is now to identify these duplicates and resolve them. The CORA dataset is a popular dataset to evaluate different approaches for entity matching, and for that reason there are already a couple of reference links which we can use. Okay, so in that case we skipped the workspace part. We already predefined the data sources and the linking task, and we go directly to the learning feature. So before that, we shortly verify. So at the moment we don't have any reference links, but as I said, in order to learn the linkage rule, we may employ existing reference links. So in that case, we already have a file of reference links, so we just import that file into the workbench. And as we can see now, the contents of this reference links is just a list of positive and negative reference links. So we have here the positive reference links which identify entities which, in that case, citations which go to the same publication, and we have negative reference links which identify pairs of entities which identify different publications. Okay, after we have loaded these reference links, we do the same as before, we just click on Start, but in that case we don't need to confirm or decline links because we already have a set of reference links. So as this is a popular data set from record linkage, which is used, as I said, to evaluate different approaches, this data set is quite hard. So that means it actually takes a couple of seconds until a linkage rule for this data set could be learned. So what our algorithm is doing now, it's basically based on a genetic programming algorithm. It starts with a very early initial random population of linkage rules, which usually are not doing very good at interlinking those data sets. Now it's applying a couple of genetic operations and tries to evolve the population into a population of linkage rules which are more closely resembling the solution domain. And we are now just waiting until it finishes these iterations, and it now improves in each iteration the coverage of the reference links. And consider that this is real time, so we didn't like cut it or shorten it. So that's why we have to wait a couple of seconds, because we didn't want to cheat like in the screencast. But okay, we are finished now, and we just wait now for the linkage rule to be viewed. And we see now that for this data set it generated a linkage rule which is a bit more complicated, because this data set, as I said, is rather noisy. So if we have a look at it, we see that this linkage rule compares by 3 properties. So first of all, it compares by the title of the publications, and these titles are lowercase than when compared by the Chakara token-based similarity metric. And secondly, we remember these are citations. So the second property we compare is the author of the publication. And the third property is the venue this publication has been submitted to. Okay, we are happy with the result. Click on Done, and we now look at the population of linkage rules I mentioned before. So at the top we can see the best linkage rule that could have been learned. But we can also have a look at alternative linkage rules. But in that case, as before, we just select the first linkage rule and we are happy with it. We load it again in the linkage rule editor, but in that case we don't want to make any modifications to it. We just trust the algorithm, and we can see that generally in these rather hard linkage rules we are not able to reach 100% full coverage of the reference links. You can see in the top right corner we get a precision of 98% and a recall of 97%. So we almost cover all reference links, but not all of them. Now usually the usual workflow is, now if we wanted to further improve these linkage rules, we can have a look at the reference links and precisely have a look at the reference links which are not covered by the current linkage rule. So here we see the positive linkage rules, and we sort them now by the score. So we want to have a look at all links which are not covered by the current linkage rule. So here we see the first instance, or the first pair of instances which is not covered by the current linkage rule. We see here, for example, that in the first citation the title is missing. So we are comparing by title, but the title is missing and the venue is also missing. So in this case, the linkage rule which has been learned is not working. So actually what we usually want to do, we want to look at the cases which are almost but not just covered by, not yet covered by the linkage rule. So in that case we see we get -3%, so we almost generated a link, but we did not, because in that case, as we can see, the title did match approximately, but the author is the same author, but it has a different formattation. So we see here that it's not exactly the same. It's the same author, but a different syntax. So what we could do now is to try to also cover these cases which have been missed and try to modify the linkage rule accordingly, usually by introducing a new data transformation which normalizes the names of the authors. But in this simple demo, for simplicity, we skip this step and we say, okay, we are happy with the result. And again, we go to generate links and generate links for this case. In this case, we don't have an output, so all we do is we just click OK and we just generate the links and have a look at them. So we now generated about 1,100 links between these citations to publications. And now we can, as well as before, we can have a look at them and look at the details under which conditions they have been generated. And again, we can sort them, yes. Okay, that concludes the second demo. We have now seen a second example of generating a linkage rule and based on that links for an example where we already have a couple of reference links. Okay, so what if you want to try Silk by yourself? So Silk can be downloaded from the official homepage, which you can see here, and we provide support for the Silk Workbench and the Silk framework in general on the Google group, on the official Google group on Silk. And Silk is licensed under the Apache software license version 2, and the complete source code is available from the assembler JIT repository. Okay, time for questions.
So thank you, Robert, very much for your presentation. Indeed, we do have some pretty interesting questions, I guess, and even if there are probably some answers in the meantime, I'm going to repeat them anyway. So the first question was if Silk can combine both local and remote sources on a single machine.
Yes. So an example for remote source, for example, would be if we access a remote source using a Sparkle data source, So in the first example, which I showed, for example, we could have used the Sparkle endpoint of DBpedia, so access a remote data source, and on the other hand, we could use for the second data source a local file, for example. So that's possible, yes.
Okay, thank you. Next question, is Silk good for linking between datasets as RDF dumps, or can it use also Spark endpoints?
So actually, its primary purpose is to interlink actually Sparkle endpoints. Mm-hmm. So the file dumps is just a secondary feature which we used in that demo to make it a bit easier. But usually you would use Sparkle endpoints.
All right, good, thank you. Next question, is it possible to automate the interlinking between the two data sources using a script? And if yes, which suitable language will be there for Silk?
I'm sorry, can you repeat the second sentence?
Yeah, and if yes, which suitable language or which language suites for Silk in that case?
Okay, I understand, yes. So yes, so Silk offers an API, so it's programmed in Scala. So you can use Java, for example. We would recommend using Scala, but it's perfectly possible to automate Silk using its API, yes.
All right, good, thank you. There's another question. If there isn't needed a so-called serious use case, to have a few more conditions for recognizing entity equivalence. For example, two movie entities could have same title, date, even same director, but then
Yes.
one is the cinema release and the other one is the DVD, for example.
Yes.
So,
so the question is if that's the problem or if that's not possible?
Well, I'm not really sure about that one. So it came from a person who knows that this is his question. Probably he can rewrite the question again, and we're just jumping to another one.
So as I understand the question, you may have the problem that the properties are called release date, for example, but actually there's something different in the release date. So
right.
how they are interlinked? So how they are interlinked? That's strongly dependent. We can see that the user actually has to confirm and decline the links. So of course the user is responsible to identify or to see how do I actually know if these two data sets are the same. And of course, if I click on the wrong buttons, if I decline a link which actually is correct, of course the result will be a linkage rule which exactly does that, what I told him.
All right, thank you. And last but not least, at the moment, there was writing somebody, supposing two third-party provided data sets have been already interlinked by their owners, for example by you, by using Silk, and if I want to know how this, how they have been interlinked, with which parameters, for example, is there any metadata existing about the linking process which is attached to the final result?
Well, yes, that's a very interesting question, but unfortunately no, at the moment we don't attach meta information in the output generated by Silk, but that's definitely something we want to work on as future work.
Okay, and focusing on that question, is it possible to see what kind of improvements or what kind of plans you do have while working on Silk on your website, for example?
No, currently we don't have a roadmap on the website, but we are always happy to discuss roads for future work on the official mailing list.
Okay.
So if there are any ideas or something like that, we are always happy to discuss it.
Okay, fine, good. There's another question coming up concerning the infrastructure. Do you need any special infrastructure to run Silk properly?
No, not at all.
Okay.
Everything which is needed as a normal desktop PC which is running Java. So what we recommend is to having a decent CPU and at least 4 GB of memory. That's what we recommend.
Okay, good. Thank you. There came up one different question. I think we do have a little time to put that one also. What is the recommended method to activate the found links? When to do, where to do with the resulting same as triples?
So the question is probably targeted on actually resolving the connected entities. So what Silk does, it generates links between entities, but what it does not at the moment is actually resolve these entities. So actually merge or fuse these entities, or how you would want to call it. So currently we are working on the linked data integration framework, which exactly does that. So amongst other, it uses Silk to generate the same as links, and it can be used to actually merge or blend the entities which have been interlinked. So I would just suggest to have a look at that.
Mm-hmm. All right, good. So thank you very much to round everything up. We had some questions here. If there are coming up some more questions, those are going to be answered by email. All of the listeners or the watchers of that webinar will get also the link to this webinar, which leads me to the outro kind of, saying hope you enjoyed staying with us, and if you need more detailed information, please feel free and visit us at www.lod2.eu, and let us please also know how we can improve to meet your expectations. I already said that there's going to be a link, and the link is to review the webinar and or to share it with others. You will find the recording also at our domain LOD2.eu. There you go, please, to the main menu block, and on the right-hand side you'll get further to the webinars. Well, don't forget to register for our next webinars. Have a great day, and don't forget, it's the end of the web as we know it. See you very soon. Bye-bye.